Next lesson is gonna be kind of long, and I don't mean this video is gonna be long. I'm talking about solving equations using inverse operations, because I could just jump in and show you an algorithm and say, memorize the way I do this and you'll be fine. Because that's not the way I work, and you won't really understand what's going on anyway, and you'll get confused, trust me. So what I'm gonna do is I'm gonna split this lesson up into 3 different videos, 3 different mini lessons. The first one, the one we're gonna do now, is an illustration of how this all works. How do I find out what a missing value is? I don't know one of these values. How do I figure it out using everything else? And I'm gonna show that on one of these balances. Okay, remember, we're finding our balance. The second video will be using a mental idea, a mental trick called backtracking, where I work backwards from, remember when Maura thought of a mystery number and then she multiplied it by 3 and added 2 to it? I'm going to show you how to do backtracking to figure out what that mystery number is. Finally, the last video, we're going to use the things we've learned here and practiced to actually follow inverse operation algorithm that we have illustrated in previous videos, okay? So the first video, we're going to use this pan balance to find a missing or unknown value. And right after this video, I actually don't have an exercise sheet for you. I have a link to Math Playground. Math Playground has tons of little interactives that you can use to practice different skills. And the interactive that I link you to is gonna kind of look just like this, where it'll give you a new equation over and over, different equations, and you will set up the equation on the balance and then figure out how to find that number. It's actually pretty fun, okay? But first I wanna show you how this works so that when you get to that link, you'll say, oh, I get that, all right? So here I have an equation, and I could make a story out of this. I could say, Johnny, is anybody's name Johnny anymore? I knew a John, I taught a John last year. John came up with a mystery number. Then he multiplied 3 by it, okay? And then he added a -1 to it, and the result was -4. So I need to know, what is John's mystery number? What is this? Okay? And I can use a pan balance to figure this out. Remember that the equal sign tells us that this, -4, is the same weight as this whole thing. So basically, this expression right here has a value of -4. Can we use that to figure out what the value of x is? We sure can. Here's how. Now, here's my pan balance, and the only thing I'm allowed to put on here are blocks. I have 3 different blocks. I have an x block, not an x box, an x block. I don't have an x box. I have a +1 block, and I have a -1 block. Those are the only 3 I can use, okay? So I'm gonna figure out, how do I do that? And I'm gonna start on this side because I only have one number to deal with here, and it's -4. So how can I use these blocks to show -4 on this side of the balance? Well, I can take these -1 blocks and put 4 of them, right? Because 4 negative ones is -4. So here's one, here's another, here's another, and here's another. If you have colored pencils or markers or even crayons, I would suggest going ahead and using different colors because it helps illustrate it and makes it pop out better. So this side's done, right? -4. This side has x's and a -1 here. Let's look at just the 3x for now, okay? I have an x block, right? How would I show 3x on my pan balance? Well, if each one of those blocks is worth 1x, then I need 3 of them, right? And these I'll just stack, because why not? So there's my 3x. But I also need to put a -1 on this side. So I'll get one more of those -1 blocks, and I'll put it right here. Now that I put these blocks on this pan balance, everything is nice and balanced, okay? This equal sign tells me that these are nice, balanced, and nothing is heavier than anything else. It's nice and balanced. What's next? Next is to get just x on one side, okay? This is very important. Basically, from now until we're done with algebra, when you see an equation, the whole point is to get the variable on one side, okay? Now that doesn't necessarily mean when we run into equations with two variables or more that we'll all want them on one side. We'll get to that later in algebra, but for now, if we have one variable in an equation, we want it to be alone. So that means we need to get this guy out of the way, okay? How do I do that? What happens if I say, I don't want you there anymore, and I go, click, and it goes away? Well, now that makes the balance go clunk. This side gets heavier, right? Because I just flicked a piece off of this side. This side is now heavier. It's all out of balance. It's a big mess. And you could say, well, that's easy. I'll just take one of these guys and go flick, and then it'll be back in balance. And that's true. But here's the problem. In mathematics, you're not allowed to just flick. You're not allowed to just get rid of something because you feel like it and you want it to go away. You have to figure out a way to make it disappear. Now, if I have a -1 and I want it to disappear, what do I add to it? Do you remember this? This is back from integers when I had a black checker and a red checker, and they meet, they explode, they destroy each other, they disappear, right? They cancel each other out. So to get rid of this, I need to bring in one of my green +1 blocks and put it here. But now that's still out of balance. Now this side's heavier because I just put an extra block here. So to bring this side back into balance, if I put a +1 here, I have to put a +1 block here as well. And notice I'm matching them up with a -1. Because when I do that, what happens? They disappear. They cancel each other out. Well, what's the point of putting a green block if it's just going to cancel each other out? Because numbers in algebra can't disappear unless you add their opposite, okay? Because that gives you 0. -1 plus +1 is 0. And I did that to both sides, so everything's still in balance. And notice on this side now, there's only x's on this side. And now on this side, there's -3, because I got one of those rid of one of those -1s, right? But I'm not quite done, because on this side I still have 3x, and I just want x. I just want 1. I want 1x all by itself. Okay? So now what I'm going to do to get rid of 2 of these guys is I'm going to do what's called division, right? I'm going to match up each x with a -1. Notice there's 3 x's right here. Each x gets a -1. If I had 9 -1s here, then each x would get 3 -1s, but that's not happening. What's happening is I have 3 x's here and 3 -1s. That means if I were to pair these up, each x would be worth -1, okay? This x is worth -1, this x is worth -1, this x is -1, and that keeps everything in balance. So if I wanted to know, and I said, okay, finally, what is the value of the mystery number? How much is 1x worth? -1. Okay? Basically, there were 3 steps there. Set it up, make this look like this using the blocks that you're allowed to use. Then get the x's by themselves on one side by canceling out whatever else is here using its opposite. And finally, if you have more than 1x, figure out what each one is worth using division. Okay? That's how your exercise is going to work on Math Playground. And like I said, it's a lot of fun. Okay? Now, I'm going to erase this scale real quick because I'm done with that, and I'm going to let you practice on Math Playground. But the last thing I want to do, because I mentioned it in the expressions unit, is I want to check my answer. Okay? Now I know what the mystery number was that John came up with in his head. He said, I think he said -1. Now let's make sure I'm right. I'm going to rewrite this equation, but instead of writing x, because I didn't know, I'm going to write what I think it is, based on the math that I just did. Okay? And then I'm going to rewrite the rest of it. And I'm going to see if this is true. Do these balance? Excuse me. This side's finished. I can't do any calculations. This side, though, I can follow the order of operations. There isn't anything in the parentheses I can do. There aren't any exponents. So let's do multiplication first. 3 times 1 is 3. Multiplication says positive times negative is negative. Rewrite everything else. Now I just have addition on this side. They're both negative, so I'm going to add their absolute values and keep the sign. And it turns out that this is correct. I figured out John's mystery number using 3 blocks and a pan scale. All right? Hey, click the link underneath this video. There aren't any exercises underneath this, but when you've played around with Math Playground a little bit and you feel pretty comfortable with building things on the scales and canceling out numbers to get x by itself and finally figuring out what x is worth, move on to the next video where we're going to try out a new strategy called backtracking. All right? Have fun with that, and I'll see you in a bit.